We're going to discuss about algorithm design. First, let us define algorithm. Algorithm is a step-by-step procedure in solving a problem, and it is a list of sequence procedures in carrying out a particular task. So, in this case, we perform a particular task. It's either sequentially or we can actually include a decision making or a repetition. It does not follow any grammatical rules. That means there's no syntax for doing the algorithm, and it represents a high level of solution to a problem. There are two types of the representation of an algorithm. One is the pseudocode, which is an English format or an English-like instructions format. And another type of a representation of an algorithm is the flowcharting. We call this as the graphical representation or diagrammatic representation of a sequence of events, usually drawn with conventional symbols. So later on, we will see that symbols representing different types, events, and their interconnections. Flowcharts or pictorial representation and a pseudocode, an English-like representations written in an instructions, are used by programmers to plan the logical steps for solving a programming problem. Some professional programmers prefers writing a pseudocode to drawing flowcharts because using pseudocode is much more similar in writing final statements in different programming language such as C++, Python, Visual Studio. In flowchart, there are two types of flowchart. We call it system flowchart. It represents the total picture without worrying about taking care of every detail. And the other one is a program flowchart, and it depicts a main segment of a complete computer program. So in our case, we're going to focus on program flowcharts. These are the following examples of a flowcharting symbol. Number one, we call this as the terminal symbol. Okay, the terminal symbol denotes the start and the end of the flowcharting. Okay, so we can include or insert text from this particular symbol and denote it as the start or the word end. The next symbol is the initialization or the preparation symbol. If in case you have a constant at the first part of your flowcharting, you can include this initialization or preparation symbol and put the variable that with a constant value. Next symbol is the input and output symbol or output box. So here we're going to include our input values and we're going to display or output the variables within this particular symbol. And we have another symbol, we call it as a decision box. A decision box handles conditions. Another type of flowcharting symbols are the process box. So we include arithmetic operations within this particular symbol. Let's say, for example, if you want to get the sum of all numbers, we need to use this type of symbol. This type of symbol is used to process arithmetic operations. This symbols is actually a connection or we call it a flow lines to connect each symbols within the flowchart. Then we have another symbols, the on-page and the off-page connector. So on-page connector is used if, for example, you are on the same page but you do not have any more much space on the first column and you need to use the second column. So you need to connect it with an on-page connector to connect it from the first column to the second column. For the off-page connector, we use this if, for example, our first page has been already used up with the flowcharting and you need to use another paper to complete and to continue your flowchart. You need to use the off-page connector and denote those page connectors with either label of letters or label of numbers. The following are the general logic in doing flowchart and in pseudocode. Number one is sequential flowcharting and pseudocode. Next is branching, or we call it conditional or selection flowcharting and pseudocode. The third one is we call it looping or iterative program structure. And the other one is a combination, meaning combination of sequential, branching, and looping. Please take note that almost every program involves the steps of input, processing, and output, necessitating some graphical way to separate them. So make sure that if we're going to start doing the flow charting and the pseudocode, we need to first analyze what should be the input, what must be the process to make the output. Program elements and structure. To complete the flowchart and the pseudocodes, we need to have program elements and structure. So these are the program elements and structure needed for flowcharting and pseudocode. Number one is constant. A constant is a literal value that does not change during program execution. It can be a numeric format or a numeric type, a character type, or a string type. So let's define first the numeric constant. Numeric constant may be an integer, we call it whole number, or a real number, or we call it decimal place or fractional with fractional components. And a numeric constant may be preceded by a positive or a negative sign. So these are examples. 10 is a valid numeric constant. Negative 28 preceded by a negative sign is a valid numeric constant. Positive 3.4 preceded by a positive sign with a decimal place using dot symbol or period symbol is a valid numeric constant. Negative 0.413 is also a numeric constant. 0 also and 201 is a valid one. Take note that there are no other characters except for period or dot can appear together with constants. So these are the following examples of incorrect numeric constants. 10,000 using a comma sign. So to make it correct and valid, so omit the comma. Next is 14.3 with dollar sign. So to make it valid, just omit the dollar sign. 10 miles per hour, unit of measurement. So to make it valid, omit miles per hour. And for this, 1/2, this is also a valid one, but in case it is invalid, how to make it a valid one? 1/2 is equivalent to 0.5. So use 0.5 instead of 1/2. Another type of constant is character constant. A character constant is enclosed with single quotation mark, and it includes numbers 0 to 9, letters A to Z, either a small letter or a big letter, and all special character like a space, comma, percent sign, dollar sign, dash, underscore sign, ampersand sign, etc. may be included. So these are examples of a valid character constant. A J that is enclosed with single quotation mark, percent sign that is enclosed with single quotation mark, a period that is enclosed with a single quotation mark is considered as a character constant. Number one, since this is enclosed with single quotation mark, we cannot say that 1 is a numeric constant, but rather a character constant. G also an example of a character constant that is enclosed with single quotation mark. Again,